Good morning, children. I am Mr. Singaya, Faculty of Mathematics. Today I am going to explain the concepts of circles. Subtopic is conjugate points, conjugate lines. 2 points P and Q are said to be conjugate points with respect to the circle S is equal to 0 if Q lies on the polar of P. See here, it is a circle. Its equation is S is equal to 0. P. It is a secant through P. These are the tangents at these 2 points. It is the polar of P, x1 comma y1. It is the polar of P of x1 comma y1. If Q x2 comma y2 lies on this polar, now take this one. Right. This line is passing through Q. These are the tangents at the ends of this. Like this. It is the polar of Q. Here Q lies on the polar of, it is the polar of P. Q lies on the polar of P. It is the polar of P. Polar of P x1 comma y1. It is the polar of Q. Polar of Q x2 comma y2. Like this. It is P. Here Q lies on the polar of P and P lies on the polar of Q. Then P and Q are called conjugate points. P and Q are conjugate points with respect to this circle. That is the concept. Again, it is the polar of P. Here Q lies on the polar of P. It is the polar of Q. Here P lies on the polar of Q. Then P and Q are called conjugate points with respect to the circle. That is the concept. If P and Q are conjugate points with respect to the circle S is equal to 0, then the condition is S12 is equal to 0. How? See here, equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay. It is the equation of the given circle. Equation to the polar of P of x1 comma y1 is formula S1 is equal to 0. Equation to the polar of P of x1 comma y1 is S1 is equal to 0. That is x1 plus y1 plus g of x plus x1 plus f of y plus y1 plus c is equal to 0. It is the equation to the polar of P, this one. equation to this line is S1 is equal to 0. Here this point lies on this line. So right here Q of x2 comma y2 lies on the above line or on the polar of P, the above line. Therefore, right here x2 x1 plus y2 y1 plus g of x2 plus x1 plus f of y2 plus y1 plus c equals to 0. See here x1 x2 plus y1 y2 plus g of x1 plus x2 plus f of y1 plus y2 plus c is equal to 0. That equals to S12 equals to 0. It is the required condition. Here, if P of x1 comma y1, Q of x2 comma y2 are conjugate points with respect to the circle S is equal to 0, then S12 equals to 0. It is the required condition. And these two lines are called conjugate lines. Polar of P and polar of Q are called conjugate lines. These two are conjugate points. These two lines are called conjugate lines. That is the concept. Conjugate lines. If P and Q are conjugate points with respect to the circle S is equal to 0, then the polars of P and Q are called conjugate lines. See here, P and Q are conjugate points with respect to this circle. It means polar of P, it is the polar of P. Polar of P is passing through Q and polar of Q is passing through P. These two points are called conjugate points and these two lines are called conjugate lines. That is the concept. Theorem, let it is a circle with radius R and L. These two are conjugate lines with respect to the circle, given circle S is equal to 0. R square in second one is R square into L1 L2 plus M1 M2 equals to L1G plus M1F minus N1 into L2G plus M2F minus N2. These are equivalent. It means if they satisfy this, then R square into L1 L2 plus M1 M2 equals to this one. But with the help of this one, we have to prove this part. After that, with the help of this, we have to prove this one. That is the case. Here, first, I am proving 1 to 2. It means, if these two lines are conjugate lines with respect to S is equal to 0, then we have to prove this part. I am proving that. Here, first one is equation of the given circle is equation of the given circle is S is equal to 0, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Its center is minus g comma minus f and radius is square root of g square plus f square minus c. Okay. Now, equations of the given lines. L1x plus M1y plus N1 equals to 0 and L2x plus M2y plus N2 equals to 0. 1, 2, 3. Here, if these two are 2 and 3 are conjugate lines with respect to 1, then we have to prove this one. If 2 and 3 are conjugate lines with respect to 1, then we have to prove this one. 2 and 3 are conjugate lines with respect to 1. With respect to 1. Here, take the pole of 2 with respect to 1. Pole of this line with respect to the circle, that is minus g plus L1 or LR square by LG plus MF minus N. But here 1, 1, 1, comma, minus F plus MR square by LG plus MF minus N. Here, with respect to this one, so right here M1, L1, M1, N1. It is the pole of this line with respect to the given circle. These are the coordinates of the pole. Here, these two are conjugate lines. So, this pole lies on this line. This pole lies on this line. Take like this. Here, it is a circle. It is P. These are the tangents. It is Q. It is the polar. Right. Here, similarly, take like this. Kitty. Right. These two are conjugate lines. It means pole of first line lies on the second line. Pole of the first line with respect to the circle lies on the second line. That is the concept. It means this point lies on this. The pole of 2 with respect to S is equal to 0 lies on 3. It means on this line. On this line. So, L2 into, substitute here, minus G plus L1 R square by L1G plus M1F minus N1 plus M2 into, write this one here, minus F plus M1 R square plus L1G plus M1F minus N1 MTF plus N2 equals to 0. I am repeating the concept. Pole of the second line lies on 3. It is the pole of 2. It lies on 3. Right. Here, minus L2G plus L1 L2 R square by L1G plus M1F minus N1 minus M2F plus M1 M2 R square by L1G plus M1F minus N1 plus N2 equals to 0. Here LCM of the denominators, do one thing. Here L1 L2 R square by L1G plus M1F minus N1 plus M1 M2 R square by L1G plus M1F minus N1 equals to, write these three terms in RHS, that is L2G plus M2F minus N2. Okay. Here LCM of the denominators is L1G plus M1F minus N1. So L1G plus M1F minus N1. In these two terms, R square is common. In these two terms, R square is common. R square into L1 L2 plus M1 M2 equals to L2G plus M2F minus N2. By cross multiplication, R square into L1 L2 plus M1 M2 equals to L1G plus M1F minus N1 into L2G plus M2F minus N2. See here, R square into L1 L2 plus M1 M2 is equal L1G plus M1F minus N1 into L2G plus M2F minus N2. It means with the help of this, that is, if L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0, or conjugate lines with respect to the circle S is equal to 0, then R square into L1 L2 plus M1 M2 equals to L1G plus M1F minus N1 into L2G plus M2F minus N2. It means with the help of this one, we have proved this one. Now, second part is with the help of this one, we have to prove this one. That is, if they satisfy R square into L1 L2 plus M1 M2 is equal to L1G plus M1F minus N1 into L2G plus M2F minus N2, then these two lines are conjugate lines. We have to prove that part. That is, see here, from 2 to 1, that is here, now from 2 to 1, okay. But with the help of this one, we have to prove these two lines are conjugate lines with respect to the circle. That is R square into L1 L2 plus M1 M2 equals to L1G plus M1F minus N1 into L2G plus M2F minus N2. Now write this part as a denominator, either this one or this one, anyone. R square into L1 L2 plus M1 M2 by, write this part here or this part, no problem, anyone. L1G plus M1F minus N1 equals to L2G plus M2F minus N2. Okay. Now, L2G plus M2F minus N2 minus R square into L1 L2, this one, by L1G plus M1F minus N1, this one, plus, sorry, here minus R square into M1 M2 by L1G plus m1f minus n1, okay, equals to 0. L2g plus m2f minus n2, write this part here and split it. Now, from these two terms, from this one and this one, in these two terms L2 is common. Observe here, L2 into g minus, here L2 is common, minus L1 r square by L1g plus m1f minus n1. Okay. In these two plus m2 f minus r, m2 is common, r square m1 by L1g plus m1f minus n1 minus n2 equals to 0. Here, see here, minus n2 is there, so we have to divide this equation by minus 1. Then minus L2 into g minus L1 r square by L1g plus m1f minus n1 minus m2f minus m2 f minus r square m1 by L1g plus m1f minus n1 plus n2 equals to 0. Okay. Now, write this one as L2 into minus g, minus into minus plus L1 r square by L1g plus m1f minus n1 plus m2 minus f plus m r square m1 by L1g plus m1f minus n1 plus n2 equals to 0. See here, minus g plus L1 r square by this one minus f plus this one, it is the pole of 2 with respect to the given circle. This one is, it is the, I am writing here, minus g plus L1 r square by L1g plus m1f minus n1 comma minus f plus m1 r square L1g plus m1f minus n1 is the pole of 2 with respect to 1. 1 means circle. Observe here, L2 this one plus M2 this one plus N2 is equal to 0. It means pole of 2, it is a pole of 2 with respect to the circle lies on 3. That is L2x plus M2y plus N2 is equal to 0. It means pole of one line lies on another line. So 2 and 3. Therefore, 2 and 3 are conjugate lines, with respect to s is equal to 0, or L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0 are conjugate lines with respect to the circle. Observe here, if these two lines are conjugate lines, then r square into L1 L2 plus M1 M2 is equal L1G plus M1F minus N1 into L2G plus M2F minus N2. And if they satisfy this one, these two lines are conjugate lines with respect to the circle. That is the answer. Find the value of k if the points are conjugate points with respect to this circle. Concept. Here it is the given circle. These are the given points. These are conjugate points with respect to this circle. Right. Steps. Equation of the given circle. Equation of the given circle, that is x square plus y square minus 5x plus 8y plus 6 is equal to 0. This one. Comparing this equation with x square plus y square plus 2gx plus 2fy plus c is equal to 0. 2g is equal minus 5, g is equal minus 5 by 2. 2f is equal to 8, f is equal to 4, c is equal to 6. g is equal to minus 5 by 2, f is equal to 4, c is equal to 6. Okay. Given points. 4, 2 and k, minus 3. Take like this. x1, y1, x2, y2. It is 1. Here, if x1, y1 and x2, y2 are conjugate points with respect to s is equal to 0, then the condition is s12 equals to 0. S12 equals to 0. That is x1, x2 plus y1, y2 plus g of x1 plus x2 plus f of y1 plus y2 plus c is equal to 0. Here x1, x2, 4 into. Here the question is, if these 2 points are conjugate points with respect to this circle, then find the value of k. That is the question. If these 2 points are conjugate points with respect to this circle, then find the value of k. That is the question. x1, x2, k plus y1, y2, g into x1 4 plus x2 plus k, f 4, y1 2 plus y2 minus 3 plus c 6 is equal to 0. Here 4k minus 6 minus 5 by 2 into 4 plus k plus 4, 2 minus 3 minus 1 plus 6 equals to 0. Here LCM of the denominators is 2. LCM of the denominators is 2. So take like this, 2 into 4k, 8k, minus 12 minus 5 into 4 plus k plus, here 4 into minus 1 minus 4 into 2 minus 8 Here 4 into minus 1 minus 4. Minus 4 into 2 minus 8. 2 into 6 12 equals to 0. 8k minus 12 minus 20 minus 5k minus 8 plus 12 equals to 0 into 2 0. Here 8k minus 5k, that is 3k. 8k minus 5k 3k. Minus 12 minus 20 minus 32 see here minus 12 plus 12. Here minus 20 minus 8 minus 28. Okay. Now k is equal 28 by 3. That is the answer. If these 2 points are conjugate points with respect to this circle, then the value of k is 28 by 3. Next question. Find the value of k if these 2 lines are conjugate lines with respect to this circle. That is the question. Then find the value of k. Here equation of the given circle is x square plus y square minus 2x minus 4y minus 4 is equal to 0. Comparing with this equation with x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay. Here 2g is equal to minus 2, g is equal to minus 1, 2f is equal to minus 4, f is equal to minus 2, c is equal to minus 4. Okay. Now radius of this circle, square root of g square plus f square minus c. Minus 1 whole square plus minus 2 whole square minus 4. Here 1 plus 4 plus 4. That is 4 plus 4 plus 1, 8 plus 1, 9, its square root is 3. Radius of the circle is 3. Now, if L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0 are conjugate lines with respect to s is equal to 0, then r square into L1 L2 plus M1 M2 equals to L1g plus M1f minus N1 into L2g plus M2f minus N2. Here given conjugate lines, these are the given conjugate lines I am writing here. Kx are equations of the given conjugate lines. Kx plus 3y minus 1 is equal to 0 and 2x plus 2x plus y plus 5 is equal to 0. Here take like this, L1x plus M1y plus N1 is equal to 0. It is L2x plus M2y plus n2 equals to 0. Comparison, L1 is equal to k, m1 is equal to 3, n1 is equal to minus 1. Here, L2 is equal to 2, m2 is equal to 1, n2 is equal to 5. Now substituting these values in this formula. Substituting the values in this formula. R square, what is the value of R? 3. R square into L1 L2 plus M1 M2 equals to L1G plus M1F minus N1 into L2G plus M2F minus N2. Okay. R square, value of R is 3. That is 9 into L1 K, L2 2 plus M1 3, M2 1. Okay. L1 K, G, value of G is minus 1 plus M1 3, F minus 2, N1 minus N1 minus 1. Right here. L2G, I am writing here. L2 2 into G, value of G is minus 1 plus M2 1, F minus 2 minus N2 5. Okay. Now 9 into 2k plus 3 equals to minus k, this one, minus 6, minus into minus plus 1 into minus 2, minus 2, minus 5. Okay. Here 9 into, it is 18k plus 27 equals to minus k, minus 6 plus 1 minus 5 into here minus 2, minus 2, minus 4, minus 5, minus 9. Okay. Here it equals to minus into minus plus 9k plus 9 into 5, 45. Minus into minus plus 9k plus 45. 18k minus 9k, write this one here, equals to 45 minus 27. 18k minus 9k, 9k, 45 minus 27, 18. K is equal 18 by 9, that is equal to 2. If these two lines are conjugate lines with respect to the given circle, then the value of k is 2. If ax plus by plus c is equal to 0 is the polar of 1 comma 1 with respect to the given circle, and HCF of a comma b comma c is equal to 1, then find the value of a square plus b square plus c square. That is the question. Here, equation of the given circle is equation of the given circle is x square plus y square minus 2x plus 2y plus 1 equals to 0. Comparing this with x square plus y square plus 2gx plus 2fy plus c is equal to 0. 2g is equal to minus 2, g is equal to minus 1, 2f is equal to 2, f is equal to 1, c is equal to 1. Now, equation to the polar of 1 comma 1. It is the given point with respect to the given circle. This one is formula S1 equals to 0. Equation to the polar S1 is equal to 0. That is x1 plus y1 plus g of x plus x1 plus f of y plus y1 plus c is equal to 0. x1 plus y1 g minus 1 into x plus 1 plus f 1 into y plus 1 plus c 1 equals to 0. Here x plus y minus x minus 1 plus y plus 1 plus 1 equals to 0. Right? Here y plus y minus 1 is 1. Y plus y 2y. Here plus 1 equals to 0. Now y plus y 2y plus 1. Here 0x plus 2y plus 1 is equal to 0. Here HCF of a comma b comma c. Now it is in the form of ax plus by plus c is equal to 0. But HCF of a b c is equal to 1. So here comparing this equation with this one, that is ax plus by plus c is equal to 0, a is equal to 0, b is equal to 2, c is equal to 1. But in the question we are asked the value of a square plus b square plus c square, that is 0 square plus 2 square plus 1 square, that is 0 plus 4 plus 1, 5. It is the